Good morning to one and all. Today we are going to study about the types of coloring. What is coloring? Graph coloring is an assignment of colors or any distinct marks to the vertices of a graph. Strictly speaking, a coloring is a proper coloring if no two adjacent vertices are the same color. Next, we are going to study the coloring planar graphs. Definition: a graph is planar if it can be drawn in a plane without edge crossing. And then we are going to study the four color theorem. We have already studied in lower classes. For every planar graph, the chromatic number is less than or equal to 4. The four color theorem. The four color theorem states that any planar map can be colored with at most 4 colors. In graph terminology, this means that use at most 4 colors. Any planar graph can have its nodes colored such that no two adjacent nodes are the same color. In 1852, 4-color conjunction is formed by Francis Guthrie, and then many incomplete graphs proved by Campy, and then 5-color theorem proved in 1890 by Yawood. 4-color theorem finally proved in 1977 by Apple Hagen. First major computer-based proof. And then next we are going to study the vertex coloring. A vertex coloring is an assignment of labels of colors to each vertex of a graph such that no edge connects two identically colored vertices. Edge coloring similar to vertex coloring except edge or color. Adjacent edges have not same colors. It have different colors. And then we are going to study the edge coloring. Every edge coloring problem can be transferred into a vertex coloring problem. Coloring the edge of a graph G is the same as coloring the vertices in a log G. Not every vertex coloring problem can be transformed to an edge coloring problem. Every graph has a line graph, but not every graph is a line graph of some other graph. Properties: K coloring. A K coloring of a graph G is a mapping of G of G onto the integers 1, 2 and so on up to K such that the adjacent vertices map into different integers. A K coloring partition B of G into K disjoint subsets such that vertices from different subsets are different colors. And then terminology. K colorable. A graph G is K colorable if it has a K coloring. And then chromatic number. The smallest integer K for which the G is K colorable is called the chromatic number of G. It is denoted by psi of G. And then backtracking algorithm. In this algorithm, we are going to study the backtrack and return false. This idea is to assign colors one by one to different vertices starting from the vertex 0. Before assigning a color, we check for safety by considering already assigned colors to the adjacent vertices. If we find a color assignment which is safe, we mark the color assignment as a part of solution. If we do not find color due to classes, then we backtrack and return false. NP hard work. NP hard work is nothing but a non-deterministic polynomial time. The class of decision problem that are solvable in polynomial time on a non-deterministic machine or with a non-deterministic algorithm. A deterministic computer is what we know. A non-deterministic computer is one that can guess the right answer or solution. Think of a non-deterministic computer as a parallel machine that can freely span an infinite number of processes. Thus, NP can also be thought of as the class of problems whose solution can be verified in polynomial time. Note that NP stands for non-deterministic polynomial time. Next, we are going to see the examples of NP hard problem. Fractional, knapsack, and then starting other graph coloring, satisfiability, and then the problem of deciding whether a given polynomial formula is satisfied. Application of graph coloring. Many problems can be formulated as a graph coloring problem, including time, tabling, scheduling, register allocation, channel assignment. A lot of research has been done in this area. So much is already known about the problem space. Thank you.